I want to welcome you to a session where we're going to go through from kind of the very beginnings to the very end of how to set up a Jupyter Lab instance and get a Jupyter notebook where you can do some real work on one of our GPUs. The first thing I'm going to show here is our documentation website at docs.chpc.wustel.edu. It has a couple of prerequisites that we're going to need to have had you go through before we do this tutorial, so I'm going to walk through those a little bit. First of all, you need an account, and in order to apply for an account, we have an account request form that's linked right here on the account side. Once you have an account, you will need to connect to the cluster, and the way that you do that is that you SSH into the cluster to this login3.chpc.wustl.edu, and you can then access your account. We'll go through that step here. Probably the more important thing, though, is to set up our SSH keys. So down here at the bottom, we have a section on entering my password to log in every time is so annoying. How can I connect to the cluster without entering the password? Well, there is a very secure way that you can access the cluster through your SSH key pairs. I like to use these instructions from GitHub to set up my SSH keys and add it into the SSH agent. Now, I've already set up my SSH keys, but if you haven't, you can go in, open up your terminal when you're logged in to your local machine, and simply do this. You do SSH keygen -t ed25519, which is a protocol for cryptography, and then you specify your email address, and it creates a new key pair. It'll ask you where to put it. The defaults are usually okay. You can set a passphrase. I set a passphrase on mine. And then you can go ahead and start an SSH agent. And so that's what we'll do here. I'm going to go ahead and start up my SSH agent for the day. And then I'm going to go ahead and add in my SSH key so that it's already registered and I no longer have to add in my credentials every time I want to SSH in. So I put in my password. I'm now have added my key. I can look through here and see that indeed I have a key added. And now I'm ready to go in. As you can see, my local username is not my WashU username. And so I need to put in my username before I put in login3.chpc.wustl.edu. And then we're going to go ahead and start agent forwarding. So here I am. I've been put on to log into, and one of the very first things I like to do when I get onto the cluster is start a screen session. Some people I know like tmux, I like screen, totally a personal preference. But what this does is it gives you a persistent session so that if you accidentally get disconnected, it doesn't mung up your whole session. So here I go, I'm in a new screen session. There are some shortcuts you can do. I'm going to do Control-A with the double quotes, and I can see what windows I have open, and I just have this one window right now. Now, I've already started a Slurm job. As you can see, it's been running for a little while, but it's on one of our GPU nodes. Here I'd like to show you what that command was to actually create that job. And so this is the command, and what you can see is I've done, sorry, I missed a character, but what you can see is I asked for an salloc, which is one of our Slurm commands. Now, if you're not familiar with Slurm, that's okay. You can go onto our website at docs.chpc.wustl.edu and go over some of the Slurm basics. And Slurm is basically our way of allowing you to get access to some of the shared computing resources on the cluster. Many people like to use sbatch, and that allows you to put all the commands you want to run into a bash file and then submit that as a job, and then it executes when there's resources available and puts the results where you specified in that bash script file. But in this tutorial, I'm going to show you how you can just ask for interactive allocations. And this is one way you can do it, is with salloc. And what it will do is it's asking for a single node, a single CPU, and one GPU. And I'm using my own account on the admin as well as the tier 2 GPU partition, and I'm asking for 3 hours. I'm not going to execute this because I have already been granted an allocation, and as you can see, it's here on GPU 02. So if I try to SSH into, say, GPU 01, oh, that's not going to work. I have not been allocated any space on GPU 01, so it denies my connection and says, no, you can't access that. But I have been granted access to GPU 02, so let's go to GPU 02 and see what it does. And as you can see, it's very happy to let me on to GPU 02. So I'm going to start a session now to do the Jupyter Lab. And I'm roughly going to follow the guidance in, again, our documentation website. As you can see, we have a lot of different things on this website, but here I'm going to go to Software. I'm going to go down to Jupyter Notebook. And this goes through some of the process of setting up a node, and then how you can look at your queue, etc. But what we really are going to be curious about at this point is how to set up Jupyter Lab. And down here at starting a server is where we're going to kind of pick this up. I'm going to use that command for Jupyter Lab, but first, rather than using the default Python module, which is described here in starting a server, I'm going to use my own Miniconda environment. Now, I love Miniconda. I think a lot of people do. It lets you control your Python environments, make sure that all the packages that you expect are loaded in the ways that you expect. And so I've already installed Miniconda. If you have not, again, we'll go back to here on our website. If you go to Software and you go down to Python, you'll see a description of how you can get the Miniconda installer and then how you can set it up on the CHPC, as well as update it and activate your environments. In my case, I've already created an environment. I've basically created an Anaconda environment with Jupyter Lab. And so what we'll do here is we'll start activating that environment. Might take just a little bit of time. Sometimes the nodes are pretty well subscribed. As you can see here, it's put me into my base environment. And what I'm going to do now is activate my own personal JLab environment. Now, all this was a conda create -n JLab, and then I specify the packages I want to install, which include Jupyter and Jupyter Lab. I usually put in pandas and a few other packages that are super useful to have. So we're going to do conda activate JLab, and what you'll see is we're now in JLab, and that environment, if I look and say which Python, I'll see that it is indeed going to my own Miniconda environment, into the JLab environment, and is using that Python. You can see I'm using Python 3.11. You can decide to use whatever Python you like. So the very first thing I'm going to do here now is start up a Jupyter Lab. So soon it will say that the Jupyter Lab has started and is available for use. In the meantime, I'm going to show you another handy tool that we like to use, which is called Visual Studio Code. And this is a freely available software. You can find it from Microsoft. It allows you to install a number of extensions, and one of the very useful extensions for us is Remote SSH. If you want to know a little bit more about how to set this up, again, I will refer to our website. You can go down here to the Visual Studio Code entry, and then you'll see how you can set up Visual Studio Code. But here I have the Remote SSH plugin or extension. And what that allows you to do is you can connect to a host when you click this icon here in the bottom left-hand corner. So if I want to, I can hit connect to host, and it will let me connect to any of a number of hosts that I've already set up on this machine. So our Jupyter Lab is now ready to go. I can now create a new window, and we're going to show you what we can do for SSHing in to this particular notebook. As you'll see here, I'm going to go back to my software and Jupyter Notebook. We're going to use SSH forwarding to get access to this, this Python notebook. So this is an example script or example one-liner that you can run. I'm going to go ahead and paste it, but I'm going to update it a little bit for my particular situation. So I'm going to go into, I want to forward this port to my own local machine. I'm going to put it into just kind of an arbitrary port I'm going to call 9876. And then I'm going to go to GPU 02, and as I can see, it's on port 8888 on that machine. I'm also going to specify that it's me that's going in, and now I should be ready to go. So I'm going to go ahead and hit that. As you can see, it was successful. I can now go to my own local host, and then I'm going to go to 9876. So I can see it's now connecting. The other thing I'm going to need will be the token. Now I could have put this into the request to begin with, but that token has already been used in the past when I was doing this tutorial a little bit earlier, so I have access to it. So let's look and see. I'm going to create a new Python notebook. Let's see if I can actually access any of the GPUs. So I'm going to go ahead and try NVIDIA SMI. As you can see, I have one Tesla V100 on this system. And now I have the ability to do whatever I like. I can run, obviously, local commands, command line commands through the exclamation mark, but I can also run any other commands that I want. And now I have access to all of my home storage. I can show you the location of this notebook. So if I save this, I'm going to save this as my test IPYNB, and then I'm just going to go ahead and add another cell here and just ls all IPYNB. And as you can see, it now shows it. So I have access to all of my local data. I have access to my the NVIDIA SMI, the GPUs, and I can run any of the code that I need to get my research done. All right, thanks.